All right, good afternoon. My name is Steve Thompson. I'm a manufacturer sales rep for Hazard Control Technologies. I'll be hosting this webinar today for my very first time, so bear with me if I have a couple technical glitches. I'll try not to do that, but I have a tendency if I can break a computer, I will. Mike Greiner, president of Hazard Control Technologies, is going to be our speaker today. And without further ado, I'm going to go ahead and let him take off. Thank you, Mike.
Okay, very good. I appreciate that, Steve. Thank you. And how is the sound?
Sounds good. No background, no echoes or anything this time.
Okay, and everyone's seeing my screen that says encapsulate the world.
Everybody's shaking their head that I can see, yes.
Okay, very good. I too would like to thank everyone for joining the webinar today. Hopefully we can learn some things about this new and amazing technology called encapsulator technology. I say new, yet the technology was developed back in the late 90s. I was actually part of a 4-man development team that developed the product. We originally developed this encapsulator agent for flammable liquid spill control. So if you have an automobile accident and fuel spills on the ground, at the time, foam was the technology and you would lay it down and put a blanket over, but then you have your firefighters walking through the foam, breaking the blanket, exposing the vapors and getting flashovers of the fuel as they're trying to extract people out of a automobile accident. So we developed this technology to encapsulate that hydrocarbon inside a thing called a spherical micelle, which we'll learn more about today, and to render that fuel non-flammable, non-ignitable, and non-explosive. How we ended up in the fire business was we sold our product to a lot of the local fire departments here around the Fayetteville, Georgia area for flammable liquid spill control. And then we would get these calls saying, wow, holy cow, I went into an interior fire attack and I sprayed the F500 onto the fire and the black smoke turned to white. And boy, the temperature went down like nothing we've ever seen and there was no steam. Why is it doing that? Of course, our question was, why are you using it for firefighting? It's a flammable liquid spill control agent. So we kind of got dragged into the fire business by accident and actually by the fire departments who originally started using the product. Now we can shift forward 24 years later, and this technology is really becoming poised to take over the world as far as a fire suppression technology. 24 years may sound like a long time. I think our biggest constraint that we had has nothing to do with the product, has nothing to do with the company, had to do that we are blazing a new trail. We are not following a path, but we're blazing a new trail and leaving a path behind us. And part of that new trail is all of the codes and standards around the world need to be updated, and we first started with the NFPA. So here's our mission: to encapsulate the world. We're trying to make it a safer place for fire prevention, protection, using this specialized, unique fire suppression agent, which is very eco-friendly, fluorine-free. It's innovative technology. Again, I mentioned it's fluorine free. We're located here in Atlanta, Georgia. That's our headquarters. We have a global distribution network with offices in certain parts of that, like HCT Latam down in Brazil, HCT Europe and Germany, HCT Vietnam covering some of the Asian rim, but we have distribution on all continents with the exception of Antarctica. We choose to be more than just a pail of product and a price book. We choose to be stewards of the industry. By that, I mean we are NFPA members. Multiple people at our company sit on the NFPA technical committees to influence the standards to bring this technology to the next level. For those of you in the United States, you probably recognize IFSTA, the International Fire Service Training Association. We're actually located out in Oklahoma. They publish a book for firefighting. We are contributors to the IFSTA to write the chapter on encapsulator technology. Also very active in the Society of Fire Protection Engineers. And I guess last but not least, our company has been an ISO 9001 registered company since 1997, and we have maintained that. And so what does that mean? That's a quality management system, which means every pail of product that you might see demonstrated, you could expect the same performance out of the pail of product you may specify or purchase. So we have consistent, reproducible results. Of course, as technology becomes new, it creates new hazards. And some of the more modern technology, like you see in the photo, solar panels, well, boy, they create electrical energized fires. We know lithium ion battery is the most rapid growing technology in the world, and it presents a lot of problems for firefighters. The old technologies such as foam don't work on it, dry powder doesn't work. And so as we have these new technologies created, we're creating these new hazards, and you'll see F500 encapsulator agent addresses all of these hazards. One of my guys would say, okay, do you want a technology that addresses all the legacy hazards on your automobile, or would you prefer to have a technology that addresses all the new hazards on your automobile, like magnesium steering columns, titanium seat covers, the lithium ion battery, while at the same time still handles the legacy fire hazards? Today, we're going to talk about encapsulator technologies, some of the features of encapsulator agent, some applications of encapsulator agent, fixed systems. Today, we're talking about concentrate control supply systems. So we'll have a little bit bigger focus on the fixed system application and provide some samples. So today we want you to understand the differences between foam and an encapsulator agent. Because our agent comes in 5-gallon pails, 55-gallon drums, and 275-gallon totes, a lot of people, and it's liquid, a lot of people go, oh, that F500 foam is really good, but it's not a foam at all. Totally different technology from foam. So we want you to understand what are the difference between foam and encapsulator technology. I want to explain the characteristics of the encapsulator agent and discuss the proper applications. We want to identify industries where the encapsulator agent can be used. So here we have potential fire considerations. Everyone's aware of the fire tetrahedron. You have the 4 elements: oxygen, fuel, heat, and free radicals. Elimination of any one of those legs of the fire tetrahedron will result in extinguishing the fire. So when we look at things like water, well, water is really focusing on reducing the heat of the fire below the auto ignition temperature of the fuel. And we're going to reduce that heat by creating superheated steam that scalds any of the inhabitants and any firefighters in the area. When we take a look at, say, dry powders, well, they're going to interrupt this free radical here, but they're not doing anything to the fuel leg. They're not really reducing the heat. They're just interrupting the free radical. And if you get a dense enough mixture of a dry powder, you're going to, inhibit the oxygen in the area. But once that cloud dissipates, your dry powder cloud, well, now you have your oxygen coming back in contact with the fuel in the presence of heat. You get a lot of reignition. One of the most popular agents that have been around are foams. In case you don't know, F500 is a Class A foam manufacturer. We used to be a Class B foam manufacturer. However, I can't get any of our marketing and salespeople to sell Class B foam because the encapsulator technology brings so much more to the table. So back in 2018 or 19, we discontinued our Class B foam line. We still offer a fluorine-free Class A foam on the market. I don't know if you can see my cursor, but if we understand foam, we're going to put a big thick foam blanket over top of the fuel, and we are going to mechanically separate the fuel from the oxygen in an attempt to smother the fire. One thing we know for sure is that if we're lying in bed at night and we're cold, what will we do? We will pull up a blanket, because that blanket will insulate us and trap in the heat and keep us warm through the night. Well, when we put down this mechanical layer of bubbles, this foam blanket, yes, we're separating the fuel from the oxygen, but we're also trapping in the heat, which is one of the reasons when we go to the foam standards, it's saying, hey, we have to apply this for 15 minutes, for 20 minutes, for 30 minutes, and depending on your flammable liquid application. And the reason for that is we can't allow the fuel and the oxygen to come back together while we still have a heat that's above the auto ignition temperature. So as we see here, we're separating fuel from the oxygen. The putting the blanket down is counterproductive to the heat reduction, and it's really limited to two-dimensional Class B fires. What do I mean by that? A flat surface liquid that you can actually put the foam on top. So if you have a flowing fuel fire down the highway, you're going to have difficulty with foam. If you have a pump seal fire, you are going to have difficulty with foam. If you have a three-dimensional transformer fire with hydraulic oil in it, you're going to have a very big difficulty putting the foam on and maintaining it on there for 30 minutes. The encapsulator agent works in a totally different principle, and we will get into those in just a moment. But these principles we work on all four legs of the fire tetrahedron. And first off, we encapsulate the fuel. So we're separating the fuel from the oxygen. We're just doing it on a chemical molecular level, as opposed to foam is doing it on a mechanical and macro level. Second, we change the heat reduction mechanism of the droplet to account to 6 to 10 times greater heat reduction than plain water. And third, we interrupt the free radicals from coming together and coalescing. So when we put all of these things together, we get an extremely rapid knockdown of the fire. We get an extremely rapid knockdown of the heat without the creation of superheated steam. And it works on a two-dimensional and three-dimensional Class B fire applications, as well as Class A and others. So this gives you just a quick overview. There was an NFPA standard, still is, NFPA 18, that's wetting agents. And basically this is, hey, we're going to reduce the surface tension of the water. It's going to help it to spread and penetrate. But we'll note that the heat reduction is the same as water, because we're going to take the outer surface and we're going to convert it to steam. If we have a reduction in the surface tension, we're going to get slightly smaller droplets, which means we're going to get more steam conversion, which means we're going to get marginally better heat reduction. And that may sound like a good thing, but you're getting marginally better heat reduction by creation of even more superheated steam that's burning the firefighters. That's probably one of the big reasons wetting agents really haven't caught on. And then we go to the next item, which is foam. And foam also reduces the surface tension. That helps to spread the blanket. across the flammable liquid. We see here that foam is a basic building block, is what we call a thin wall bubble structure. We put thousands of bubbles together, we form a blanket, we separate the fuel from the oxygen. And as we already talked, some of the limitations there, it's counterproductive to the heat reduction, actually traps in the heat. Here, the basic building block of an encapsulator agent is something called a spherical micelle. And we'll show that coming up here next. But we do reduce surface tension, so it aids in spreading the micelles. We encapsulate the fuels in the vapors to render them non-flammable, non-ignitable. We change the heat reduction mechanism to drive the heat into the center of the droplet. And we'll talk in greater detail about how that happens. So we provide 10 to 20 times faster heat reduction than plain water, wetting agents, and foam. At the last slide, you saw, oh, we were 6 to 10 times faster. Well, it's actually 10 to 20 when we start including foam, because foam's trapping in the heat, we're removing it. And we interrupt the free radicals. So encapsulator agents. These agents are now covered under NFPA 18A. This is the standard for water additives for fire control and vapor mitigation. And it's effective on A, B, D, lithium-ion battery, as well as pressurized three-dimensional fires involving both hydrocarbons and polar solvents. More specifically, encapsulator agents are covered under, this is the qualification test. Just like you have UL 162 is a qualification test for foam. So what is that? A lot of people hear UL 162. So it's a pan fire and we're going to spray a foam on there. And what we're really doing is we're qualifying, does this agent create stable bubbles in the presence of the high heat that's generated by the fire, that's capable of smothering the fire, and are the bubbles stable enough to provide burn back resistance? That's UL 162. A lot of people think of that as, oh, that's the fire test. Well, really, if you look at it, we're using the fire to test the stability of the bubbles. In 18A, section 7.7, this is called a spherical micelle stability test. So this is a qualification test to determine, does an agent create stable spherical micelles, which is the basic building block of the agent, that's capable of encapsulating the fuel, and is that encapsulation stable in the presence of high heat over a period of time? And we'll get into what that test is. So we're a water additives, spherical micelles capable of encapsulating carbon and both polar, non-polar, as well as hydrocarbon liquids and vapors. That's important, and I don't want to gloss over this. We can encapsulate both a hydrocarbon liquids and a hydrocarbon vapors. So now with this agent, we're going to see in the new 18A standard that's coming out, we're going to see some new technology introduced to the marketplace called VEEP, Vapor Encapsulation and Explosion Prevention Systems. This is going to be a very exciting new time, because rather than waiting for these vapors to find a hot spot in your plant, they can be detected, they can be encapsulated and prevent explosions and fires in the first place. So what we're doing is we're encapsulating that fuel to separate the fuel from the oxygen on a chemical molecular level.
Encapsulator technology, the next generation of fire and hazard mitigation.
Mike, a little more volume.
First, we start with a simplified version.
I'm sorry to say, more volume?
Just a little more volume, yes.
Tell you what, let me use no volume and I'll talk us through this. So we're starting here with the simplified version of the molecule. It has a polar head on one side, which is soluble in water. I always remember polar bears love water. On the other side here is a non-polar tail. This is hydrophobic. It hates water, fears water, and will do absolutely anything it can to get away from water. So when the agent goes into the water, what happens is,
Encapsulator technology.
oops,
The next generation of fire and hazard mitigation.
it's not letting me stop
First, we
it.
start with a simplified version of a single encapsulator agent molecule.
Sorry,
consisting
hang
of
on. I'll start this over.
The next generation of fire and hazard mitigation.
Can you hear that now, Steve?
First, we start with a simplified version.
It's
of
a little low, but I can hear it.
Agent molecule consisting of a
Mike, if you go under options, you need to choose enable sound.
and a hydrophobic non-polar tail which fears water and will do anything to
All right, help me out here.
So under your view options, that drop down at the top of the screen, it should have enable sound.
Okay, I'm sorry, but I'm not seeing view options. You're talking about on the bar?
Yes, at the top of the, I'm not sure if it's view options. That's what it says on mine. It's not there completely. But yeah, at the top of the screen.
Is it within the PowerPoint or on the?
No, it's within Teams,
Within Zoom.
within
Yeah, within
Zoom, I'm
Zoom.
sorry.
It's
Yeah.
at the very top. You gotta put your cursor up there and it'll pop down.
The problem is my Zoom screen's not up because I'm running this PowerPoint presentation.
Yeah.
So I just have a little scroll bar. Unfortunately, I'm not seeing that more. Give me one moment to end this PowerPoint presentation and see if I can bring up the stop sharing. Okay, now I'm up here. Okay, guys, now you want to help me out now that I got the screen up?
When you share your screen, Mike, in the drop downs with the screen share, there's going to be one that says like enable embedded sound. You have to be sharing to enable the sound.
All right.
Okay, I'm sharing. Can you see my screen?
Yes.
Okay, this is what I have.
Yeah, it's within the Zoom.
Yeah, I mean, I'm in the Zoom now. I got this here. Share sound.
That's it. Share sound.
Okay.
Now that should play the sounds in the video, the recordings in the videos.
We try to teach an old dog new tricks and look what happens. Okay.
Encapsulator technology,
What's better?
the
Now we
next
got-
generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
Okay. Here, a couple of points that I want to make here is because we've been in the foam business, we understand very clearly that the foam is, or let's say the quality and the quantity of the foam is really based on the equipment. Because you're taking an agent, you're air aspirating it, you're creating bubbles. And if we go to our UL 162 or go to Underwriters Labs online website, we'll see that if a foam is UL listed, it's not really the agent that's listed. It's the agent listed with a foam nozzle and a foam eductor. And I think it's important to understand that, because when you take that product and then you put it through a different device, it actually changes the performance of the foam. The big difference between that and the encapsulator agent is, if you recall, once the agent goes into the water, and it doesn't matter if it's fresh water, salt water, or brackish water, it instantaneously and automatically forms spherical micelles. And then when a droplet comes out of a nozzle, and it doesn't matter if it's a monitor, if it's a sprinkler head, if it's a rotating nozzle, if it's a hand line, once that droplet comes out and is formed, those micelles closest to the surface break apart, forming this F500 skin on the surface. So think about the F500 droplet. This happens instantaneously and automatically every time, regardless of equipment. That's one huge advantage from the performance standpoint of the encapsulator agent. So I always think of this droplet, the F500 droplet, to be like an orange. The peel of the orange would be your F500 encapsulator agent molecules. The non-polar tails are sticking out because they hate water. The polar heads are on the surface. And then the pulp of the orange, the stuff you eat, would be your H2O molecules. That's this blue water. And then inside we have the seeds of the orange, which are the spherical micelles. The difference between this droplet and an orange is this droplet has so many seeds, you wouldn't want to eat it if it were an orange. Very critical what we see here. We are changing the substance on the surface of every droplet. Somebody once told me
Encapsulator technology.
Somebody once told me you can't change physics, and my response to them was, we're not changing physics, we're changing the material on the surface of the droplet to something different. This just shows us that when we're talking about micelles, we're talking about molecules. So that's by angstroms, 1 × 10⁻⁻⁻. So these micelles are extremely small. So what we're trying to show here is that if a water droplet were the size of Earth, the micelles inside this droplet, and there's billions and trillions of them in every droplet, would be the size of the peas. What that micelle does for us is provides 3 really unique features. The first one is encapsulation of the fuel from the oxygen. The second thing the micelle does is changes the heat reduction mechanism of the droplet to account for extremely rapid cooling without the creation of steam. And the third one is the interruption of free radicals, which between encapsulation and the interruption of free radical proactively is scrubbing the environment of toxins, which is very beneficial to firefighters or anybody who might get caught in an interior fire. So what we're doing here with this mice, with our droplet configuration, is creating a thermal circuit. So how I like to look at this is that when you have H2O, it's kind of like an onion. You're converting the outer layers to steam, and it's not very efficient. I look at the F500 molecule can transfer heat like a Ferrari race car. The H2O molecule transfers heat like a bicycle. So when you look at the F500 droplet, we're very rapidly, like a Ferrari, transferring heat through the surface and around the surface of these millions and millions of micelles in the interior of the droplet. We're transferring heat like a Ferrari, but then slowly, like a bicycle, we're transferring that heat out into the H2O molecules that are on the interior of the droplet. So what's happening there is we're driving that heat into the internal portion of the water droplet. We already talked about section 7.7, and if we go into 7.7, it says you use a certain amount of the agent, you put in a certain amount of fuel, and you add in a certain amount of water. In the NFPA standard, they leave this to the discretion of the actual manufacturer. They didn't want to tie it down to just one product like F500. They said, well, maybe somebody can do this, but they would have a different mixture. So our mixture for the F500 encapsulator agent is 1 part of F500, 8 parts of fuel with 40 parts of water, and mixed together. And I'm going to show a video of the actual NFPA 18A section 7.7 protocol. Interesting ratios here is the ratio of 1 part of F500 to 40 parts water is 2.5%. That's why we use the F500 at 3% for Class B fires. It's giving us a 20% factor of safety. So we're taking 2.5% and we're applying at 3. Most of your equipment, your proportioning equipment, is all geared for 3%. This is a very important ratio too, because 8 parts of fuel to 40 parts water reduces down to 1 to 5. So this allows, and we'll see this in the next edition of the standard, will allow the fire department to say, oh, I got 20 liters of fuel spilled on the ground. They can easily say 20 liters times 5, that gives me 100 liters. So now if I lay down 100 liters of a 3% solution, not a 2.5, but a 3% solution, I've actually applied 3 liters of F500, and each liter can encapsulate 8 liters of fuel. So 3 times 8 is 24. So basically what this is doing is allowing the fire departments to come forth, and we have a nice little spreadsheet that allows them to do that. Eventually, I think we'll get it into an app, but allows them to estimate how much fuel is spilled on the ground and determine the amount of 3% solution to be added. So that's another tool, and all that's in an appendix in the new 18A standard. So this is the spherical micelle stability test. Here we're demonstrating the NFPA 18A section 7.7 spherical micelle stability test. So in that test, we're mixing in a gallon of gasoline here. In the test, it allows you to test to gasoline, heptane, alcohol, any type of fuel, just to demonstrate that. So when you go through your listing process, you will have to go and test each fuel so that we can determine, does this agent create spherical micelles capable of encapsulating the fuel? So we've put in this case, a gallon of gas. We have now mixed in 1 pint of the agent. And now I have a 5-gallon GPM nozzle. So we're going to apply water in here for 1 minute. And that gives us that 1:8:40 ratio. Oh, come on, quit messing with me. And then after you've encapsulated, you wait 1 minute, and then you have to apply a flammable torch to the entire surface of this pan. So if this agent is a wetting agent and does not form any foam blanket, then this pan will instantaneously ignite because we haven't blanketed the fuel and we haven't encapsulated the fuel. So hence the 1 minute test. And now you can see the ground is wet here because we are going to come back 2 hours later. You'll be able to well, here's 2 hours later. So the test requires, after you encapsulate, that you do an initial fire test at 1 minute, and then you do a second fire test after 2 hours. What we're trying to accomplish here is the agent capable of forming spherical micelles, the basic building block of an encapsulator agent? And can those micelles encapsulate the fuel? Are they stable in the presence of high heat, hence the torch here? And are they stable over a long period of time? So you have the 1 minute and the 2 hour. When we look at a foam test, the foam test just has a 10-minute burn back resistance. It doesn't have a 2 hour burn back resistance. So here you can see, not only did we encapsulate the fuel, rendering it non-flammable, non-ignitable, we were able to pass the 1 hour and the 2 hour. That's one of the QA/QC tests we do with every batch we make. And in addition to that, I've actually done a 2-day test and a 2-week test, and still stable after 2 days and 2 weeks. The third thing that this free radical, the spherical micelle is doing for us is it's reducing the toxins. We're actually interrupting the free radicals from coming together, which results in the reduction of the toxins. This was a study done by Clemson University, their wildlife and environmental group. So what you see here is burning toluene, and we have a plenum right here and a chimney. We have a light source that's going through the thing to a transmitter over on the other side that's measuring the amount of light coming through. So we did 2 different tests. Each test was done 3 times. The first test was just plain water being sprayed through the smoke flume. And again, we looked at the light, looked at this soot accumulation right here on the plenum, and also sampled this soot and looked at the soot and smoke toxicity. So we did 3 tests with plain water, 3 tests with a 3% F500 solution, and these were the results. So we had a smoke reduction of 68%. So we had an increase in the visibility of 68%. So what we're doing is we're stopping these free radicals from coming together to form toxic soot and smoke. The soot accumulation on the plenum was reduced by 97%, and the smoke and soot toxicity was reduced by 98.6%. These are really big values when you consider the cancer among firefighters is 30 to 40% higher than any other occupation on planet Earth. And we've been using foam that does nothing to proactively address this issue of reducing the soot and the smoke and the heat without the creation of free radicals. And then on top of that, has fluorinated ingredients in it, which themselves are also toxic. Hey, good lead in here, because we're talking about the global PFOA, PFAS crisis that's coming to a head. And there are entire countries and states within the US issuing foam bans on Class B foams. Many of the fire departments are seeking fluorine-free solutions. The problem we're finding is that the fluorine-free foams require 3 times the application density than the fluorinated foam. So now you're applying 3 times as much. And on top of that, the cost of them is more expensive. So for a fire department to move from a fluorinated foam, which are being banned, to a fluorine-free foam, their cost just went up by a factor of 6 to 10. Yet we have encapsulator technology. We're not trying to form bubbles because our basic building block is spherical micelle. So therefore, we don't have any fluorine in our product. These are the applications for the encapsulator agent. Class A fires, Class B 2-dimensional fires like polar, non-polar, flat spill fuels, things like that. Class B 3D. We now break this out into 2D and 3D because we know foam is a viable product for Class B 2D fires, 2-dimensional fires, but in the standard itself, it says it's not suitable for 3-dimensional. Since foam's not suitable for 3-dimensional, that gives you 3 options: water, and even more water. And yet we have an encapsulator agent that can encapsulate those fuels and literally smother a 3-dimensional flammable liquid. It works on Class D fires. And the reason it works on Class D is, remember what our droplet looks like. It looks like that orange. So we've changed the substance on the surface. So now when an F500 encapsulator agent droplet comes onto a Class D fire, well, guess what? We don't have H2O coming in contact with this high burning temperature metal. So we remove the separation of the hydrogen and oxygen in the explosions. So again, a whole new avenue for fire protection engineers, a new avenue for NFPA. We're currently working with the Minnesota Fire Marshal on a project to educate them on what this droplet looks like and why you can use an encapsulator agent on Class D, but you can't use plain water. Works on Class K, kitchen fires, lithium-ion battery fires. In fact, I would have to say, based on my knowledge right now, the encapsulator agent is the only agent that's proven itself to be able to extinguish lithium-ion batteries and provide burn back resistance of lithium-ion batteries with acceptable amounts of solution. About a month ago, we had a Tesla fire, car fire in Texas, Houston, Texas. They used 30,000 gallons of water, and basically it just burned itself out. We provide fire protection for Tesla at the charging stations, at the Gigafactory, and they've had 4 fires and you've never heard of them because the F500 snuffs them out immediately and provides burn back resistance. I put in here energized environment. I don't want to say we can use the agent on Class C, but we have done testing to where you can apply agent onto three-dimensional Class B transformer fires in an energized environment. As long as you're applying it at a certain spray patterns and standoff distance, you won't have the electricity feedback to the nozzles. So that's why we have energized environment there. This is just a quick
Hazard Control
overview of
Technologies presents
different
F500
applications.
encapsulator technology.
See the black smoke here just absolutely disappear. That was due to the interruption of free radicals. Here you see the black smoke instantaneously turning to white. Here we extinguish a car fire with 20 GPM. We use more solution just to test that the agent was flowing. This is a diesel fire, 25-foot diameter pit. This is Fuller solvent. This is ethanol. This is your three-dimensional flowing fuel fire. There's no way to even put a foam blanket in here to address this, yet F500 handles them pretty easily. This is a gas fire. This is LNG gas. Is actually a lithium-ion battery, which is kind of an A, B, C, D type fire, depending on the makeup of the battery. This is your Class D. I don't know if you've ever seen just plain water on a Class D, but this will be blown off like fireworks. Real live transformer fire. FDNY just showed up. Now they're putting F500 on it. They use that for all their transformer fires. FDNY has standardized on the F500 encapsulator agent for all of their transformer fires. And I'm surprised by how many they actually have there. So them and Con Edison have joined together and have written their own SOGs, because again, we're blazing a new trail. Their own standard operating guidelines on being able to apply encapsulator technology to three-dimensional Class B fires in an energized environment. They're also using it for lithium-ion batteries, which you'd be surprised how many of those skyscrapers have lithium-ion battery charging stations in the basement. The fixed systems. We have three different systems. The first two we use very regularly. Bladder tank systems, water-driven proportioners, and balanced pressure pump systems. I can say over the last 24 years, we've really only used one balanced pressure pump system, and it was on a Goodyear rubber tire facility. It was 600,000 square feet. They were 3 racks high with their storage, wanted to go to 4 racks high. Code called for a secondary high expansion foam system. Goodyear says we don't want that because, geez, if the fire doesn't get the tires, the high expansion foam system will ruin them anyways. And so we put together a proposal, went to the authority having jurisdiction, which was the fire marshal in Memphis, Tennessee, and got the approval. So that's the only balanced pressure pump system that we have in place at the time. But that was 4,000 gallons of F500 that's proportioned in at 1%, protecting 600,000 square feet of rubber tires in Memphis, Tennessee. The bladder tanks and water-driven proportioners, we do quite a few of. So this is the makeup of a bladder tank. The bladder tank has a steel tank with a rubber bladder inside. The bladder is a squeezable bladder. So the concentrate is your yellow, goes into the bladder tank. And then you have water that comes into the side of the tank right here. Steve, can you see my pointer?
Yes, I can, Mike.
Okay, thank you. And so here's your riser pipe, and this is the riser pipe that's actually going up to the hazard. This could be a monitor, it could be sprinkler system, could be a VEEP system, could be any type of open head deluge. And so what happens in this system is the concentrate is in the tank and all the way up to this, which is called the hydraulic actuated control valve. And so you have the water pressures on the side of the tank. And this can be either above the deluge valve, or can be plumb below the deluge valve. We have multiple ones in place. And when a fire is detected, the deluge valve opens up. It sends a water up to here that opens this. Concentrate flows into this ratio controller, and here you get the mixture of the concentrate with the water. And from this point forward, you have an environmentally friendly, fluorine-free, eco-friendly solution of F500 encapsulator agent. So looking at it in real time, this is the bladder tank in the back here. This is your deluge valve. So the water is coming up from here and then going here up to some hazard. This probably, based on the size of the tank, is probably protecting a class A because it's a smaller tank. We're probably proportioning at 1% for class A. I would suggest this is probably protecting a conveyor belt that handles coal at a power plant. So what happens here is the deluge valve, the fire's detected, the signal comes in, opens the deluge valve, water starts flowing here. In the meantime, on the dry side of the valve, coming up here, is a pipe that's going to open our hydraulic actuated control valve, which is this yellow piece. You can actually see the pipe coming in, a little backflow preventer here. And now the agent, which is coming up out of the tank. So the agent is being squeezed up out of the tank, coming this way, is now free to come this way and enter into here, which is our ratio controller. So this is all plain water. This is all 100% concentrate. And then from here up to the hazard, we're now bringing a solution of F500 to the system. So we have multiple systems of these in place for both Class A and Class B 2-dimensional, Class B 3-dimensional, Class D, and lithium-ion batteries. So we have these systems in place for all of those hazards that our clients need to have protected. This particular project, we had a 36-gallon tank for the transfer point, 4 50-gallon tanks on the conveyor system, the dust collectors and the day silos, 3 100-gallon tanks. So these are throughout the whole entire coal handling system. One of the reasons they're specifying the F500 is they're handling the Indonesian coal, It's also called subbituminous coal. Here in the US, we call it Powder River Basin coal. And when you put plain water on that coal, the coal dust floats up on the plain water, floats down your conveyor, still on fire, and causes an explosion, or potentially causes an explosion, where we're encapsulating that dust, extinguishing that fire. Oops. So here's another Xcel Energy, same thing, Tolk Power Station, Harrington. The second system is a what we call WDP, water-driven proportioner. We have our own brand, HET Diamond Doser, that we've tested and compatible with our agent. Just giving you a quick schematic showing you what this is. I like to think of these as fuel injection systems. That's your water housing. Now we're adding the injection system for the agent. So this part here is the water-driven proportioner that shows up at the job site. Ours is configured a little bit differently than this. I just use this animation to kind of show. Basically, the contractor's cutting the pipe, the fire protection contractor, putting flanges on. In our case, we can provide flanges or Vitalic couplings to connect to your existing piping. So your water is going to flow here through this and then up to whatever device you want to feed. You can feed a monitor, you can feed a sprinkler system, pre-action sprinkler, you could feed a open head deluge system. So the water goes through. I like to describe this as turning the hamster wheels that are attached to a gear. The gear is pumping the pistons, and it's bringing the solution over to whatever your device is that you're going to deliver it out. This here would be your agent tank. Basically, it's feeding agent X, pumping it into the water. So the faster the water flows, and the faster the pistons go. So it's very accurate through a wide range. With the bladder tank, you can't use those with a closed head system because if only two heads open, well then you don't have enough flow to proportion. But with the water-driven proportioner, if two heads open, then you have enough water to be able to proportion if 10 heads open. That just means water's flowing faster through the water throat. So you get the idea here. Here in practice, this is at a power plant. So in this application, it required 275 gallons of agent. So we're able to supply it directly in a 275 IBC tote. And based on that, we supply a spill containment unit. So this tote fits right on the unit. And then the agent feeds into the water-driven proportioner. In this case, the water's coming this way, goes through the proportioner, and then it's going up to the hazard. In this case, It's going 2 locations. One is to a sprinkler system in the coal silo, where they use for washdown and fire suppression. So it's a hybrid system. And then it's also branching off to a standpipe in the tripper room so that they can do manual firefighting using a washdown nozzle or the HCT piercing rod. So that, you can use this again for both fixed systems and manual systems. Let me end the show there for a minute. I want to come here. This is on our server. This is the completed projects for our CCS systems. So we can see we got a lot of power projects, a lot of coal. We have under turbine lube oil, that's Cascades 1 and 2. To move down, here's some in Canada. These are Wisconsin. This is pulp and paper right here. Currently, we're working on a project with Rex Lumber in Florida. They have 5 mills, 1 in Alabama, 1 in Mississippi, and 3 in Florida, I believe. And so we're currently working using F500 to proportion in using water-driven proportioners into the sprinkler system, protecting the wood drying kilns. And I think I saw Ron Lowry was on here. Next week, we're going to Alabama to walk 13 sawmills, pressure treating mills, and I think they called them fabrication mills because, this is a customer of Rex, and Rex said, we saw what this agent can do. We lost a kiln because the water couldn't keep up and put the fire out. And the customer we're going to see next week said, oh, we had the same problem. The water was overcome and we lost the entire kiln, $4 million. So we got a call, went down and visited with them. So pulp and paper, protecting that. And some of these things that I'm showing you, you have to understand that prior to an encapsulator agent, you wouldn't put Class B foam in a paper mill. You wouldn't put it inside a kiln to try to, protect the kiln. These applications didn't exist prior to the encapsulator agent. So we are breaking new ground. Here's metals. This was a Metco in Elwood City, Pennsylvania. They had a lithium ion, it's a recycling facility. They had a lithium ion battery fire, took down the whole facility. After showing the local folks on how effective F500 was on lithium ion battery, the authority having jurisdiction said, you can rebuild your facility only if you have F500 in it. And so these are a bunch of fixed systems, power, pump power. Here's a rubber tire. I know we have some of Liberty Tire folks in place. Here in Calhoun, we have a fixed system in place to help protect their rubber chip. These are ones I wanted to show you. I don't include these in my PowerPoint because HCT has signed non-disclosure agreements with Tesla, but you can see GC1 charging station, GC2, GC3, 4, 5, 6, 7, and now we have 8. We've done the hot oil anode rooms, the skid rooms. These, when we went out and do the commissioning, hopefully there's the agent. So these are the pipes leading up to the actual charging room, and these charging rooms have 4 racks, if you will. Each rack is 6 high and maybe 50 long. So they're doing close to 300 batteries they're charging in these racks, and they are protected with F500. So this is a typical design and layout. So here we have the F500 system, agents feeding down. It's feeding into the diamond doser water-driven proportioner here. So this is the water coming in, it's going through the water throat, agents coming this way, it's feeding in, and from this point forward, it's solution. And depending on which one of these activates, the solution goes to the sprinkler system. And the way they have these set up is each one of these is pretty much the same scenario. Here's a close-up of the diamond doser. Again, water's, in this case, the water's coming here. Agents over here in the corner. It's being fed through this pipe in here and then comes here. So it actually, the water's coming through here, agents mixing here, and from here it's going to the hazard. This here is just a test port that we use, that after we run the system, we have a solution. It comes out through the hose, we collect it in the bucket, and then we run refractometers to test to make sure it's actually proportioning at the design rate, which in this case is 3% for lithium-ion batteries. If it was the pulp and paper, it could be 1%. The rubber tire one that I at least showed the project folder on with Liberty Tire was 1%. So we come out and verify that everything is proportioning correctly. So it just gives you a broad view of the agent, the spill control. Spill control is optional. We need to have the feed line even with or slightly higher than the water-driven proportioner, so the agent will feed in. In the power industry where we've used some of these, we've had tanks as big as 2,000-3,000 gallon tanks that are feeding into the water driven proportioner. It just turned out with Tesla that they have a nice, neat design, and the amount of stuff we're protecting and for the time frame we're protecting, these became pretty cookie cutter, and they're nice little systems and very easy to install. We can do totes 275, we can do 350, we can put two totes together, that makes 550 gallons, and then we just interconnect those totes. One can sit on top of the other or side by side. You just connect them together, feed in here at the single spot. So we try to use totes whenever possible, just because it saves you the hassle from having to pump agent into a standalone tank. But it doesn't always work out that way when you have a 2,000 gallon holding tank. Then we have to go to a separate standalone tank. There's some more coal applications, power, Dominion Mount Storm. Some of these projects were pretty big with some pretty big tanks. Like this was a 3,000 gallon bladder tank, or maybe 2,500, I don't remember now. But in this tank here is going to protect 5 transformers and 2 under turbine lube oil. And then they have the same thing on the other side of the plant. That one is protecting 1 under turbine lube oil, which is a 3D class B, and 10 transformers. So what they're doing here on this project is they poured the concrete slab. The tank is so big, they drop it in place. Over here, you're seeing the header pipe, and then they got different risers that are going to the different parts. So in here, they'll probably have anywhere from 5 to 10 deluge. The snow is no extra charge for the snow. And it does work in warm weather climates just as well as the cold weather. No, eventually this is a heated environment. The agent itself needs to be stored between 35 degrees and 120 degrees. And so they'll eventually build the room around this. Let's see if I have some. Yeah, so this is the side of the building. You can see the transformer. So they have the one tank on this side of the building over here, one over here, and they're protecting 10 transformers and 3 under turbine lube oil. It just gives us the idea of the size of the transformers. And what they're protecting are the step-up transformers that are just outside of the power plant. So on the other side of this wall is the generator, and that is the most expensive piece of equipment in a plant. So they're protecting that with the under turbine lube oil utilizing 3% F500, and they're protecting these so that if they catch on fire, they can extinguish them so that it doesn't perpetrate into the power plant. I don't know why it does that. Sometimes you close a file and it closes the whole folder. You can see we've done a lot of work with Dominion Power, multiple plants. We did a lot of testing with Dominion Power. Then we see some other Embrower. This was Embrower is now bought by Boeing. This is an aviation one where we're actually protecting the Class A materials. So this, I believe, was a 900-gallon bladder tank. And in this scenario, they have composite materials for airplane automotive parts. They knew that the plain water wouldn't work, wouldn't put out the fire. They got introduced to the F500 encapsulator agent from our Brazilian partners. And we actually set up some sprinkler systems and did a plain water versus I don't remember if this was 1% or 3% F500 on their commodity with the local fire department authority having jurisdiction. The result was the water failed miserably. The F500 put the fire out, and we could hand these parts to the authority having jurisdiction because they were cool to the touch. And they said, we approve the product because we were flowing at the exact same densities. I don't believe, I think we just have pictures of the tanks and some of the fire protection, but not of the material that's being protected. So we can say that we have aviation experience there. There's another metals. Quebec is a metals. New Zealand. So we've put systems into Indonesia, New Zealand, Grand Cayman, different parts of the world. And really what people are looking at is, what does this encapsulator technology do for me to protect our facility? That's the main thing that they're looking at. And then the systems themselves, we have the means to be able to get it into the water. A lot of times they ask, do you do the design? Typically, you'll have a local design build fire protection contractor. We work with them on getting our equipment. So in this case, we have a contractor who installed all the piping, all the sprinkler. We provided this component. We provided some connection components between the agent and the water-driven proportioner. We provide the spill and containment in most cases, and the agent. And then we come on site as a subcontractor to them to provide the commissioning and certification service. I'm not going to take much more time. This was about CCS. I will just blow through this. These are three-dimensional Class B under turbine lube oil. I showed you some of the projects. The reason the F500 is very capable of three-dimensional Class B fire suppression. Other things like water is not very good at Class B, and foam is not suitable for Class B. FM Global did a test and they said, hey, this fire gets to be so hot, it reached over 1,500 degrees at the ceiling. And that is hot enough to compromise the structural integrity of the I-beams. And so they recommend going to a higher sprinkler density using plain water, because they understand foam doesn't work on three-dimensional fires. So we came in and we did some testing with the Minion, because the Minion said, hey, if the problem is the heat, the F500 reduces the heat 10 to 20 times faster than plain water and foam. So let's add F500 to our existing systems. So we came in and we did some tests with them, very controlled fire protection engineer, the insurance guy. This guy here is from Aegis Insurance, fire protection engineer that oversaw this. This gentleman here, Mark Boone, sits on the 850 technical committee. He is actually the chairperson of that committee. So they're examining. We test 0.15, 0.2, 0.3, and 0.4. I don't know if this video will run. Let's see. No, that one doesn't run. So this is plain water versus the F500. Now remember, on these sprinkler systems that
13, 14, right now. 11,
1,200 degrees.
the ones at Dominion are designed with a sprinkler density of 0.3. So I asked Mark Boone, why are we testing 0.2 if everything you have is 0.3? He said, well, I feel pretty confident what the F500 will do, but I really want to test it. So they cut the sprinkler density down, and in 11 seconds, we put the fire out, provided burn back resistance, cooled everything down. With the plain water here at 0.2, we can see we've got a little bit of burning, and it's around the edge because the water's not cooling the steel. And what do we have in the under turbine lube oil is tons of steel. So you still have a heat source to keep igniting your fuel. That's one of the main advantages of that heat reduction characteristic. So not only are we encapsulating all the vapors, taking the fuel, separating the fuel from the oxygen, we're rapidly reducing the heat, eliminating the ignition source. So this continues on for about 2 minutes. So at the same density, we extinguish 10 times faster than the plain water. And so then we looked at how did we do versus the 0.4. If we're going to take a 0.3 system and upgrade to 0.4, I need 50% more water. I need a bigger pump, bigger pipes, bigger sprinklers. I've got millions of dollars to go from 0.3 to 0.4. It doesn't seem like a lot, but it's millions of dollars. Here we already see the F500 put this out at 0.2 in 11 seconds. It's always fun to watch it a second time. Looks like the water is keeping up with the F500, but again, at first glance, it looks like it's keeping up, but what? We still have the heat that it can't reduce. That is one of the major keys here. Get rid of the heat, get rid of the fire, get rid of the ignition source. So here we're actually extinguishing the fire 3 times faster at half the sprinkler density. And to me, I was there. I witnessed this firsthand. Mark Boone was there. He witnessed it firsthand. That's why when you look at all of our fixed systems, you see, wow, Dominion, we've got a lot of projects with Dominion. So this shows the very rapid temperature reduction versus plain water. Here, when they turn the sprinkler off, you get your typical hump back where it's coming way back up again. So you don't get the hump back with the F500 because once it puts the fire out, the solution continues to absorb heat rather than allowing the heat to come back. They also, so here was the difference, 0.2 versus 0.4 was 3 times faster, also reduced the heat more, so led to multiple projects. And just show them. Transformers is another big application.
Hazard Control Technologies presents F500 encapsulator technology.
Yeah, I'm going to blow that video off. You guys can look at it later. Again, we've got 3-dimensional type fires. This was one of the fires that occurred in New York City that actually brought New York City to encapsulator agents. So this magazine gets circulated to about 80,000 firefighters. They had a transformer in Queens. There's 3 separate articles here. This one is written by Mr. Sanfilippo, Stephen Sanfilippo. You notice here it says foam manager. They don't call him the foam manager anymore. He's the encapsulator technology guy now. So the transformer caught on fire. They used 1,500 pounds of purple K dry powder that just pissed off the fire. When that's not working, the next natural reaction we see fire departments do is let's start a foam operation. So they started a foam operation, applied foam for about an hour. Of course, it didn't put the fire out because the transformers are 3-dimensional. The foam just rolled off the top of the transformer down into the Bronx River, which caused hazmat, because now we have foam going down into the Bronx River, leading to an environmental issue. So hazmat shows up. This is Lieutenant Cassidy. He was on duty when he showed up. He then suggested to the incident commander, which is this gentleman, Stephen. Here's the incident commander, 31-year veteran. Maybe you should try this F500 encapsulator agent. So the foam manager said, sure. They pulled a pail off the hazmat truck. They put the ejector in, dialed it up at 3%. 1 minute and 30 seconds later, the fire was out and was cool to the touch. And Sanfilippo said, holy cow. It said something different, but holy cow will summarize what he said. what kind of foam is that? And Cassidy said, it's not a foam, it's a different technology known as encapsulator technology. And here in the article, he starts talking about F500. It's not considered foam, which FADNY is used to. We use it on transformer metal fires. Now they're using it on, it says a myriad of other uses. So they're using it on lithium ion battery fires. And I can tell you that my area manager, Mr. Ron Lowry, who's on here, he heard me tell this story and he just thought, oh, a minute and a half, cool to the touch. That's some Mike Greiner embellishment. So he wasn't believing that until he himself went to New York City and was dealing with these guys in the hazmat group and the special ops group. And this gentleman, Mr. Cassidy, stood up and was talking about F500 and talked about this incident. And Cassidy said, we put the fire out in about a minute and a half and everyone walked up. The transformer was cool to the touch. And Ron said, well, I won't believe you, Mike, but when Cassidy says it, I believe it now. So just to know that they're now on board using it. And because they came on board, they started to do leakage current testing with F500. So they understood that F500 is not a foam. So they tested some AFFF, some AFFF, and F500. They tested them on 50,000 volts. The desired result was, we don't want 0.9 milliamps to come back, because at 0.9 milliamps is when you start to feel a sensation of a tingle. And so both the foams exceeded 0.9, but the F500 was well below that. So what does it mean? It means that if you take foam and you apply it in an energized environment, because you have bubble-to-bubble interaction, you will get a current feedback to the nozzle, which can be very dangerous to the firefighter. But with the F500, they achieved very good results, which then said, hey, let us go ahead and look at F500 through 3 different nozzles with various flows and pressures at 345,000 volts. Our goal is less than 0.9. Let's see what happens. Steve, can
On
you hear
October
that?
15, 2010, Con Edison and the
Yes, it's
FDNY
fine.
conducted a live suppression test at the Fresh Kills 345,000 volt substation. The purpose of the test was to measure leakage current from the high voltage conductors back through the suppression agent to the fire department apparatus. Hello, my name is Anthony Natali, and I'm with Substation Operations Emergency Response Group. Before we get to the results, here's a brief history on the project. In 2006, we began a joint venture with the FDNY to prove that water could be safely used in a high voltage environment to extinguish or protect equipment impinged by fire. 2 recent incidents caused us to rethink our response posture. We realized that we needed to look for a product that will allow us to knock the fire down quickly without compromising the safety of first responders. Along with the FDNY, we looked at the products available on the market and chose 3: AFFF, alcohol-resistant foam, and F500 encapsulating agent. Preliminary testing was conducted at the Fire Academy using a disconnect switch energized to 50,000 volts. The current leakage values from the AFFF and alcohol-resistant foam exceeded the established safety limit of 0.9 milliamps, but the F500 agent produced leakage values similar to that of water, which we already knew to be safe. F500 does not fall into the category of traditional foam. It is considered an encapsulating agent capable of providing quick knockdown coupled with heat dissipation. These promising test results enabled us to move forward and conduct a live field test at the Fresh Kills substation. The selection of this site was driven by our need to conduct the testing on the highest voltage that the fire department could reasonably encounter.
For the Con Edison fire suppression test, the FDNY provided 2 pumpers and a tower ladder. Hello, my name is Battalion Chief Steven Sanfilippo. All 3 were used to apply F500 fire suppression agent to the live bus at Con Ed's high voltage station in Staten Island. All our equipment was grounded before any testing commenced. 1 pumper was on a hydrant taking in water and also supplied water to an additional pumper which had F500 concentrate in their booster tank. We mixed it to a proportionate and then used the 3 means of delivery. We used a fixed mounted multiversal nozzle at ground level, a deck gun, and a tower ladder. The nozzles were wired up to measure any residual voltage at these various distances and spray patterns.
For this test, it was my task to come up with the circuitry and equipment. With the field technicians, we connected up the equipment so that we could determine which distances was safe to spray the F500 concentrate and water mixture on live bus. My name is Tim Sieben, and I'm a technical manager for protective systems testing here at Con Edison Substation Department. What we ended up doing was we set up a portable van at the substation, regrounded it, and then stretched wire to the nozzles. We also installed a safety gap, which is very important in limiting any voltage coming back to the equipment, preventing any damage or potential safety hazards. The wire that was connected to the nozzles was run back to a 5,000 ohm resistor, which simulates someone holding that nozzle. We were able to measure current coming back from the F500 concentrate and water mixture. It was measured by a digital ammeter and 2 analog meters. A digital fault recorder was also installed to record the electrical waveforms, so later on we could go back and look at the exact data on a computer.
The testing philosophy required us to look at a variety of ways the foam could be delivered by the fire department in order to prove each method safe. The safety target for leakage current is 0.9 milliamps or below. 0.9 milliamps is the level at which leakage would cause a physiological effect, basically an electrical shock as we know it. In the first test, we used a fog pattern. F500 was delivered from a fog nozzle at a 30-degree pattern onto the 345,000 volt overhead conductors from a test stand. Leakage current back to the delivery nozzle was measured and recorded by our technicians during the test. We began the test at the 25-foot standoff distance from the conductors, and the readings varied from 80 to 90 microamps. We continued to move the stand closer in order to identify any significant changes in leakage. At the 15-foot mark, there was a minimal increase to 105 microamps. This indicates that the fog pattern is the safest method of delivery. The second test was a solid stream from the engine. The next process called for the delivery of F500 from the fire department engine using a 2-inch smoothbore tip. The test began at the 85-foot standoff distance, where we received current readings from 2 to 4 milliamps. This exceeded our 0.9 milliamp safety threshold. At that point, we began to back up from the conductors in 10-foot increments until the current leakage values dropped to the acceptable threshold. At 95 feet, the current dropped below the safety target of 0.9 milliamps. We have now established a safe standoff distance for this delivery process. In the third test, we used a large caliber stream from a tower ladder. Again, we began the test at the 85-foot mark using a multiversal nozzle, which delivers a large volume of water, in this case, 500 gallons per minute. This actually had no effect on the test process. We determined that the most conductive method of delivery was from the solid stream, so the apparatus, volume of water, or pressure had no influence on the current leakage values. Moving forward, we will be meeting with the fire departments that support the Con Edison service territory to discuss the test process and conclusions. This data clearly indicates the process to be safe and may ultimately change the way these fires are fought. Our goal is to ensure the integrity of the infrastructure, but more importantly, keep fire department members safe while operating in these high voltage environments. When you ask people to go against the grain of what they believe, you can't tell them that it's safe, you have to show them. Thanks for watching and stay safe.
So what you see there is we're just dealing with a totally different agent that works on different principles. So we're really expanding the market. This was what they came up with as their conductivity testing standoff distances for their 3 different types of nozzles. They've actually created a new standard operating guideline. So it's interesting how the agent has started to take off in many industries. This was in 2018, I believe. This is just a quick comparison. I actually have a separate PowerPoint for this comparison, but Alabama Power, they have an F500 CCS system in place. They had a fire. They caught the fire on the transformer on their security cameras that's attached to their smokestack, and it took 3 minutes and 10 seconds to extinguish. There was no human interaction, no firefighters, 100% extinguished with the encapsulator agent. They told me 3 gallons. I think this is a little light because they're probably flowing maybe 40 to 50 gallons a minute. So maybe 150 gallons of solution. So for only 4 to 5 gallons of agent were used. Pretty small cost. They said one of the biggest things was that everything was 100% contained in the containment. So the transformer was garbage. They disconnected the fire protection, took the transformer out. They had a new one shipped in from another plant because they had a spare. He said the rocks inside the containment were charred. We dug those out. We pumped the solution out. We put the solution to our wastewater treatment plant. We put in new rocks. So it was just a truckload of rocks. Put the new transformer in. We were back in operation in 3.5 days. They had a second transformer fire. It was at a Georgia power plant. They used foam. That's not what I'm showing here, but they used foam, but it was very similar to this one. 6 hours to extinguish, multiple fire departments, 50,000 gallons of water and solution. In this case, 400 gallons of foam. Agent cost 8,000, cleanup cost maybe $1 million. And that's what Georgia Power experienced. They took them 4 hours. They were using a foam, couldn't get it out. They had an injury during the process, and everyone knows that cost a lot of money. They had about $1.5 million environmental cleanup bill, and it took 6 weeks, so they couldn't even get to put a new transformer in until the environmental cleanup was done. So it was at that point where the corporate risk engineering contacted HCT and said, we want you to come to our headquarters. We are going to spend money on F500 concentrate control supply systems that put these fires out rather than spending millions of dollars on environmental cleanup and injured people. So we have done a lot of business with Alabama Power. So again, just go through some of these, so understand that, you know, we can provide fixed systems, we can provide emergency response trailers. This year's called a turbo cannon. I show this because I know what's coming in the new NFPA 18A standard. So we'll be seeing a lot more of these turbo cannons. This is just diesel fuel. Here you can see the agent now, see the agent on the ground. mist, a lot of surface area, a lot of non-polar tails sticking out, tremendously great heat absorption. I think the gentleman there was very impressed. So we see this as being something that could be sold with refineries for vapor mitigation to encapsulate the vapors before the explosions. We provide these type of things in conjunction with the water-driven proportioners for odor control at various waste stations. So we have some of those applications in place. Here, what the Navy did is they decided to put this on deck on their aircraft carrier so that they could actually extinguish a burning aircraft that might crash on the deck. Before, when it crashed on the deck, the colonel there told me, you know how we put out fire? If an airplane, a $30 million aircraft, crashes on the deck of our aircraft carrier, he goes, first, we're moving through the water. If you try to put foam on top of it, it just blows off the back of the ship. Just by the movement of the aircraft carrier, it is impossible to put foam on that fire and keep it on the fire. So you see that D8 dozer over there? Yep, that's our fire protection. We pushed this $30 million aircraft into the water because we're not going to sacrifice a $1 billion aircraft carrier for a $30 million airplane. But this now gives them the ability to snuff out the airplane, keep the airplane, and save themselves a whole bunch of money. So these are just some of our solutions that have been in place. We have literally applications for Class A, Class B, Class B 3D, Class D, and lithium ion battery in place with HET fixed systems. And then we provide a whole bunch of mobile apparatus as well. Like these we call QAMUs. We have 20, 50, 75, and 100 liter quick attack mobile units. We have the carts, for mobile response to piercing rods. So we can do loose and mobile equipment. We can do trailers. We do consulting and training. We are going to do assessments next week at the lumber mill, different trainings. I know we've done some stuff in the rubber tire industry, going through and doing some plant assessments. So I'm going to open it.